Okay, so what we're determining here is whether the quadrilateral can be a parallelogram. Now, in number 28, it says the diagonals are congruent. If it was a parallelogram, then the diagonals being congruent means that it must be a rectangle. However, it says here that the quadrilateral has no right angles, so it can't be a rectangle, because rectangles have 4 right angles. So since it's got congruent diagonals, but has no right angles, then it can't have been a parallelogram, because any parallelogram with congruent diagonals would be a rectangle. So I would say it this way. And just to give you an example of something that might fit that definition, if you had an isosceles trapezoid like this, you would have congruent diagonals, okay? And that has congruent diagonals, but it doesn't have any right angles. So, sorry, I'm trying to draw that line straight. So that would be an example of something that has congruent diagonals but no right angles, and of course that's not a parallelogram. Okay, in this problem we also have diagonals that are congruent. So since we have diagonals that are congruent, as we discussed in number 28, the only way for us to have congruent diagonals if it's a parallelogram is if it's also a rectangle. So do the other two conditions prevent it from being a rectangle? And it says 2 opposite sides are 2 centimeters long. So that seems to be fine. We can have opposite sides equal in length and in a rectangle. So what I wrote here is, since the diagonals are congruent, which they are, then it might be a rectangle if the other conditions don't prevent that from being true. The other condition states that the opposite sides are 2 centimeters each. This could be true in a rectangle. And if so, it would then be a parallelogram. Now, it might not be this. It says, the question is asking whether it can be, not whether it definitely is. And so I'm just going to talk about that really quick. Just like number 28, you could have, if you look over here at 28, you could have that and that congruent. Those could be the sides that are 2 centimeters each, okay, and have the diagonals congruent. So it could be that, meaning not a parallelogram, but there's nothing preventing it from being a parallelogram based on the information they gave us. You could be a parallelogram with diagonals each 3 centimeters long and with the opposite sides 2 centimeters long. So there's nothing preventing that from being true, so we're going to say yes, then that is possible. Okay, on to the last one. Okay, so for number 30, there is a pair of opposite angles that are right angles, but then the quadrilateral isn't a rectangle. So what that kind of suggests is that you've got 2 right angles, but the other matching opposite set of angles can't be equal, because there would be 180 degrees left to split between them, and they're not splitting them equally. If they were, then it would just be a rectangle. So that means you have some shape that doesn't have 2 opposite pairs of angles congruent. You have one pair that's right angles. That would mean that if the other pair was also congruent, they would be splitting the other 180 degrees. So what kind of figure could look like that? First, let me write out what I was saying. Then I'll show you a figure that would look like that. Okay, so how do I write this? In a parallelogram, both pairs of opposite angles are congruent. Since we're told that one pair is congruent and each measures 90 degrees, they say they're right angles, then 180 degrees remains to be shared between the other angles, and if they were congruent, they would have to each measure 90 to split that equally and be equal measure. And this would make a rectangle. So if it's not a rectangle, then it doesn't have 2 pairs of congruent angles like a parallelogram does, so it can't be one. Now, what would that figure look like? I'm just going to draw a big sketch across the top. I'm going to actually do my drawing tool here, see if I can pull this off in green. And I'm going to say we have a 90-degree angle like that, and a 90-degree angle like that. And what we really have here, if I extend those successfully enough, what we really have here is like a kite shape. Okay, so you do have 90-degree angles, and again, let me try and make it a little bit better. Okay. You do have 90-degree angles both here and here, but what we've done is just kind of change the other angles. They are summing to 180 between the two of them, but they're not equal, and so they look like this kind of shape here. So that's the possible thing that it could be, and so if it says the quadrilateral is not a rectangle, then there's no way then that it can be parallelogram. It's not just that it might be, it's just that it just absolutely can't be. So let me get that out of the way. Just wanted to give that little demonstration. And that's it. Those are our answers. I hope that those make sense. Ask me questions if you can't make sense of that. Okay, and I just realized when watching my video, this video that I uploaded to YouTube, that when I delete something at the end, it doesn't ever allow it to be shown in the first place. And I want to figure out what my settings are that are causing that. But in the meantime, I'm going to draw the image that I was describing, that you, of course, didn't see. I'm going to draw it right now. Okay, so here you can see something that meets the conditions of number 30. Two opposite angles are right angles, but the quadrilateral is not a rectangle, and that means that it wouldn't be then a parallelogram if it's this way, because if you were to change it so that the opposite angles that you see, let me mark them in blue, here and here, if you were to change them so that they were 90, then it would have to be a rectangle. So in number 30, then it can't be one. Yeah, sorry about that. I'll figure out the settings so that I can make something that I draw and then delete, appear and then disappear rather than just not show up in the first place. Anyway, hope that helped.